Hello students, welcome to our practice session. You've had a chance to work through the problems. Now we will go over the answers. So in this first problem, we're given the supply and demand equations. We're going to try to find Q, the equilibrium quantity. So we have two equations and two unknowns, so let's start this way. I can sub out Q and I get that 2600 minus 5p equals minus 1000 plus 10 times p. Next, I can move that 5p to the other side and I'll get 15p. I can also move that minus 1000 to the other side. That gives me 3600. So p equals 3600 over 15, and that works out to 240, I believe. Yeah. So that's P star, that is the equilibrium price, but the question here wants equilibrium quantity. So now I've found equilibrium price, I can plug that into supply or demand to find equilibrium quantity. It doesn't matter which one I plug it into. That's because in equilibrium, supply equals demand. So you'll have the same answer either way. I'll just plug into supply because that looks a bit easier to me, but if you plug into demand, you'll get the exact same answer. So you have minus 1000 plus 10 times p, but we just established that p is 240. That comes out to minus 1000 plus 2400, which is 1400. So that corresponds to choice D over here. Now, next question asks about equilibrium price, but we already found that on our way to find equilibrium quantity, so we've got that one. So that wraps up problems 1 and 2. So just set supply and demand equal to each other and solve with basic algebra. Moving on, let's talk about problem number 3. So if winter is going to be really cold, how will that affect the market for coats? So let's set up our supply and demand diagram. Now, to be sure, the question does not ask you for a supply and demand diagram, just asks you about price and quantity. However, you should always draw the diagram. The diagram helps you see what's going on. In the past, a lot of my students would skip drawing a diagram and just try to reason through it, and that usually does not go very well. Draw a diagram, and it's hard to go wrong. So, if the winter is really cold, that's going to affect consumer tastes. Consumers will want coats more than they would have earlier. They probably already have a coat, but now they want a warmer one, so they'll be buying more coats than they would have been otherwise. So that's going to shift demand out. Remember, consumer tastes were among the things that shift demand, not supply. So now I can trace out the effects on price and quantity. Looks like price will rise and quantity also rises. So that's choice A. So again, whenever you get a supply and demand question, always draw a diagram, even if the question does not ask for a diagram. The diagram shows you what's going on, and that information helps you answer the question. All right, problem number 4. So James is a consultant. He's getting $40 per hour. Ethan is getting $10 per hour. James has to get someone to mow his lawn. Must be a really big lawn because it'll take 2 hours. So how much would James's opportunity cost be if he spends 2 hours mowing a lawn? Well, if he earns $40 per hour, that's going to take him 2 hours. It means he's giving up 2 hours that could be spent doing consulting. So 2 hours spent mowing a lawn is 2 hours not consulting and 2 hours not getting paid $40 per hour. So James has to sacrifice $80 of income in order to mow his own lawn. So you might think, if I mow my own lawn, I'm not paying anyone, so it's free. That's missing the point. That's missing opportunity cost. He's still missing the money he could have been earning by working instead. But because he's mowing his lawn, he's not working. He's missing out on that money. Now for Ethan, his wage is $10 per hour. So if he spends 2 hours mowing a lawn instead of working, he's only giving up $20. So if James asks Ethan, can you mow my lawn for me? Ethan would say, well, I could spend those 2 hours working instead, earning $20, so no. You gotta pay me at least $20 to make it worthwhile. So if Ethan gets paid more than $20 to mow a lawn, Ethan's willing to do it because his earnings from lawn mowing in that case, if they're bigger than $20, would exceed his opportunity cost. Now James, on the other hand, is willing to pay anything less than $80. If he works 2 more hours and gets $80 and pays something less than that, like say $65, he's better off. So James is spending $65 to take care of the lawn, but then he's getting paid $80 because he's working instead. So James is better off. Ethan would also be better off because Ethan normally only gets $20 for 2 hours of labor. If he's getting instead $65 for 2 hours of work, that's better than his usual rate. So Ethan is also happy. Now his other options here don't work. So choice C, if James only pays Ethan $15, Ethan's going to say no. He'd say, I'd rather work for 2 hours and earn $20 than get paid just $15 for spending 2 hours on your lawn. Option A here also does not work. That's because if James can pay Ethan to mow the lawn, that frees up James to work for 2 more hours. However, 2 hours of work for James is only worth $80. You're not going to spend $115 to earn $80. That does not make a lot of sense. So James would be unwilling to pay Ethan $115. So only choice B would work here. Moving on, let's talk about number 5. So this is clearly written before COVID. So pre-COVID, we used to have guest speakers come to campus physically and give a talk in person. And Alfred can either go to the lecture and learn about economics, or he can go to the movies with his friends. If he decides to go to the lecture, what is his opportunity cost? Choice A here is missing the point. Opportunity cost is not just about how much money you spend, or how much money you're not spending in this case. It's about the value of that next best option. So his next best option is going to the movies with his friends. So he's going to a lecture, he's giving up this opportunity. Price of the movie ticket would also not be his opportunity cost. So only choice B works here. So that's number 5. let's talk about number 6. So we're trying to find the price elasticity of supply. So remember from our book, the supply elasticity is we have change in Q over average Q. Then we divide that by change in P over average P. So now we plug in our numbers. So change in Q goes from 5,000 to 10,000. Average Q would be the average of 10,000 and 5,000. That would be 7,500. Change in P, prices go up from 15 to 20. Average price, we have the average of 15 and 20, and that averages out to 17.5. So, I guess you don't need a calculator, you can probably work this out, but you can see why it might help to have a calculator handy when you are taking the exam. So you have 5,000 over 7,500. At top over here, and these last two zeros cancel. And you have 5 over 17.5. So 50 over 75 is going to be 2/3. And 5 over 17.5 is going to be 10 over 35. And that'll be, so you have a fraction of a fraction, you can multiply it by the reciprocal. So that'd be 70 over 30, which is 7/3. And 7/3 is roughly 2.33. I guess we're rounding a little bit. So that's how you would solve that one. So know the formulas for elasticity and then plug in the numbers and you got number 6. Moving on, number 7. Looks like another elasticity question. So for the cross price elasticity, our formula was you have the change in quantity for good A over average quantity of A. In the bottom you have change in the price of good B over the average for good B. So let's plug in and solve. So quantity went from 100 to 150. The average quantity would be the average of 100 and 150. So you average those two numbers together, you get 125. Change in price went from 150 to 250. For the average, oh, it's a mistake. This should be average price of B. So average of 150 and 250 would be 2. So we get 50 over 125 at top. And then we get 1 over 2 down here. Again, you don't need a calculator. You can still work it through in your head if you're good with math, but it would be nice to have one during an exam. So fraction over fraction is multiplied by the reciprocal. So 2 over 2, these guys cancel. And we're left with 100 over 125, which would be 4/5. And 4/5 in decimals is 0.8. So that happens right over here. So that'd be choice D. So because that cross-price elasticity is positive, you can tell pencils and pens are substitutes. So you typically use one or the other, but you might not be buying both of them. If the cross-price elasticity were negative, that'd be when you have complements, things like hot dogs and hot dog buns, which go together. So it makes sense. If pencils get more expensive, you start using pens instead, so there's more demand for pens. So that's why I get this positive relationship. So you just have to calculate the number for that question, but I wanted to give you that extra intuition so you get a fuller understanding of what's going on. All right, let's talk about number 8. We're trying to find consumer surplus. So the price is 45, and consumer surplus is the gap between what you actually pay and what you are willing to pay. So for Priscilla, she's willing to pay up to 65, but she's only paying 45, so she's getting $20 of consumer surplus. So she'd be willing to buy a pair of shoes at that price and get some benefits from it. Is Pandora also willing to buy, even though she's not as willing to pay? Well, she's willing to pay up to 50, and the price is just 45, so it's still a good deal for her. She's also willing to pay at that price. Now, if Priscilla was a pair of say $40, then she would not buy because you wouldn't pay $45 something that's only worth 40 to you. And if she doesn't buy, she doesn't get a consumer surplus. But in this case, she is buying, so we add her in as well. 50 minus 45 is 5, so total CS would be 25. All right, number 9. So Pac-Man costs $1 to play. Street Fighter is 50 cents. Street Fighter gives her 10 utils, so 10 units of utility. So now we're asking, how much utility would she have to get from Pac-Man to pick Pac-Man over Street Fighter? So the key here is we said in chapter 16 that consumers want to maximize utility per dollar. So with Street Fighter, utility per dollar is we have 10 utils over 50 cents, half a dollar. That comes out to 20 utils per dollar. with Pac-Man, we get an unknown number of utils. But we know the price. The price is $1. So it's already in per dollar units. That makes things very convenient for us. So some number of utils per dollar. So you're trying to make the utils per dollar as big as possible. You just want to pick the one that has the larger utils per dollar. So this had better be at least 20 to make it prefer Pac-Man. Because if this were say 21, then she gets more utils per dollar, more happiness per dollar from Pac-Man than Street Fighter. And if it gives you more happiness per dollar, that's the one you want to go for. So it has to be at least 20 to be bigger than utils per dollar from Street Fighter. So that'd be choice E. Very last problem. Looks like we have a double shift here. So we have a change in the price of flour and also a change in the price of cream cheese. These would probably be examples of something you'd see in the section of more difficult problems. So you got double shifts. We do each shift individually, and then we draw a table to look at their combined effects. So the price of flour goes down. What does that do? Flour is an ingredient to making bagels. If one of your ingredients gets cheaper, then that's a reduction in your costs for the firm, and that's going to shift supply. Supply is going to shift out. So now producing extra bagels can be worthwhile because it's cheaper to do it than it was in the past. So that shift on its own tends to decrease price. It would also increase quantity. So that's our first shift. We're not done yet. We also have to talk about this second shift. A lot of people eat bagels with cream cheese. So bagels and cream cheese are complements, kind of like hot dogs and hot dog buns. So if the price of cream cheese goes down, what does the law of demand tell us? Law of demand says we'll buy more cream cheese. And if cream cheese goes along with bagels and we're buying more cream cheese, that means we also want to buy more bagels. So we're going to increase our demand for bagels. So demand is going to shift out. So we start over here, old demand, old supply. Then we go up there, a new demand. That's going to push prices up. It's also going to increase quantity. So that's how you look at the individual shifts. Now we have to combine them. So we had this table we talked about in chapter 3. You draw a table with your arrows in it for each individual shift. Then we talk about their combined effects. So our first shift pushed prices down. So the price of flour fell. That tended to decrease the price of bagels. Now, our second shift when cream cheese got cheaper, that made bagels more expensive. For quantity, quantity rose with our first shift, so that gets an up arrow. Quantity also rose with our second shift. So with quantity, both shifts are going in the same direction. They're both increasing Q, so Q has to be going up overall. With price, it's unclear. First shift lowered price, second shift raised price. We don't know which effect is stronger. So that's going to be ambiguous. I might say it's indeterminate. So the effects go in opposite directions. They don't always cancel out. One effect might be bigger than the other one. We don't have enough information right now to say which effect is bigger, so that's why I say effect on P is unclear. So let's go and look at our options. So this says price will be indeterminate or unclear. Quantity goes up. Oh, that's what we said over here, so that has to be right. So that wraps up our practice session. Study hard for that exam, and best of luck to all of you. Stay safe out there.